So we have Luciano. He's going to tell us about the Pingo project. Pingo. It aims to make interconnecting small controllers of all sorts easy and transparent. So go ahead. Oh, ready?
Oh yeah, we're rolling.
So, hi everyone. Thanks for having me here. Thanks, Carl, for bringing me here. So Pingo aims to be a universal API for hardware hacking. So what's the idea? Basically, we have these different kinds of boards, and we want to use the same API to program all of them. So basically every board that is suitable for physical computing have GPIO pins, right? And so you have digital pins, analog pins that have an AD converter. You have some digital pins with PWM support. This is out of place. Anyway, this is about me. Well, I'm not going to talk about me today. So Pingo was born in Garoa, which is a hackerspace in São Paulo, Brazil, founded about 3.5 years ago. It was much smaller than PS1, which is awesome. I visited yesterday and Monday, but it's an open space. Everybody can come, and we have open nights every night. Basically, that's the philosophy of Garoa. So what's the problem that Pingo aims to solve? So we have some activities for beginners at Garoa, and one of them we call the Arduino Coding Dojo, in which we have this basic circuit with a pot and a 7-segment display. And basically we want to do an animation on the 7-segment display that is controlled by the pot. For instance, the pot controls the speed of the animation, or the whatever is displayed there, different things that can be done. And this is kind of like a Hello World version 2, because the Hello World of the Arduino world is just making an LED blink. This is more interesting because it has input, right? So it's interactive. So it's slightly more interesting than just blink. So we can do that with the Arduino as well, right? Because it has a bunch of GPIO pins that sort of emulate the Arduino pins, and this is the circuit for doing that with the Arduino. It's pretty simple. And we can also do it with the Raspberry Pi, because it also has a bunch of GPIO pins, but in the case of the Raspberry Pi, that particular circuit is more complicated because the Raspberry Pi doesn't have any analog input. So in this case we use this chip. This is a MCP 3008. It's an AD converter, but we managed to make that simple circuit work. And for instance, there's also the Pingo One Black. It has a bunch of pins, among which some are analog input pins, so the circuit again is simple. But the thing is, those pins can be controlled. Almost every one of those boards can be programmed in Python, and you can either program them in the Python that's on board for the boards that run Linux, or they can be remotely controlled by Python, which is the case of the Arduino. I didn't bring a Raspberry Pi with me, but I have an Arduino here that I'm going to use for the demo. So the Arduino is not powerful enough to run Python on board, but you can control it remotely using the Primata protocol over serial with a few libraries. We actually started using one, and now we switched to this other one. And so this is an example of a Python code for doing that coding dojo example in the Arduino. And what's interesting about this code here is that we're missing an import statement over there, but it's basically just importing time and OS, which are standard Python modules. So this code doesn't use any special library, because the Arduino offers this kind of CSFS interface for programming the GPIO pins, which means that you have the pins mapped to file-like objects in the file system, and you write and read from them, and that's how you program them. So it's not too long, and it works. So the main loop here is where the interactivity goes on, right? So we basically cycle over the numbers of the segments, of the different segments in the 7-segment display, and then we turn it on, and then we use this function analog read, which we define here, to read one of those files that is linked to the analog 0 pin, and then we sleep for a time that is proportional to whatever we read here, and then we turn it on or turn it off. So this is basically, and then we go to another segment. So this basically does like a sequential animation of the segments around the perimeter of the display. Okay. So this is and now here this is the code to do the same thing with the Raspberry Pi, and it's actually a bit smaller. But this is deceptive because we are using two libraries that are pretty big and that are specific to the Raspberry Pi. Okay? And the APIs are different. And for the BeagleBone Black, again, this is the shortest code, but we are using another specific library. But if you think about it, what we are doing is all the time the same things. We are turning on and off digital pins, and we are reading analog input from an analog pin. So the idea of Pingo is to offer a standard API for doing that across all boards. This is a tradition in the Python community to try and standardize APIs for the things that are similar, like for instance, database, right? So there's the PB API, which is a Python standard that says you're going to write a driver for a SQL database, follow this standard, and your driver will be interoperable with whatever program uses that API. So this is the same idea applied here. So how does this work? I'm going to do a little demo. And this is, of course, the dangerous part. This demo is more reliable on a Raspberry Pi, but it works here too. Because on the Raspberry Pi, then I would have Python running on the machine, on the board itself. In this case, I have to use the serial link, which kind of dies when I'm not looking at it. So let's get started with the demo.
Try to shrink the window a little.
Yeah, let me get the bottom of it showing also. Otherwise, yeah. Okay. All right, so I go into Python. I have Pingo installed. Pingo is already on the Python package index, so you can do pip install Pingo. And so from Pingo, import star, because for the demo I want everything. And what do I have now? I have a bunch of things that I imported, right? Not so many things. So some of these things that you will recognize as the name of boards, like Arduino is a board, Arduino is a board, RPI is the Raspberry Pi. These are actually Python packages that implement the drivers for the different boards. And so and there's another interesting thing here, which is there's a package called detect. So that's what I'm going to use. So what I'm going to do is I'm going to create this variable ART, standing for the Arduino, and I'm going to do detect my board. Okay, so like I said before, we just switched from PyFirmata as the underlying library for doing this communication to PyMata, because PyMata is more up to date. We actually submitted patch requests for the PyFirmata library, but the maintainer was not very responsive. So, and then we discovered this other library which is more actively maintained, and we switched to that. So what we have now is an object which is an instance of the Arduino Firmata class, and this says that we are talking to it through this serial connection, right? So again, using one of the Python introspection features, which is the dir function, I can inspect the attributes of this object, the board, right? So it has a bunch of things that are specific to Python. These are actually hooks for Python metaprogramming, those things with 2 underscores in the front and the back. There are some methods that we consider private, that you only need to deal with those methods with the underscore if you are implementing a new driver for Pingo, and not when you're doing day-to-day programming with Pingo. But there is one attribute here that's named pins. I should cut off here. Yeah. Okay. So let's take a look at pins. So ARD pins. If you know Python, you know this is a dictionary, right? So this dictionary maps pin identifiers to pin objects. So let's grab the pin that's connected to the LED. I have this LED here connected to pin 13. So I can do LED equals ARD pins 13. Okay? So what is the LED? LED is an instance of another class called digital pin. And this is the digital pin 13. So what can I do with it? Well, I can, again, inspect it. And I'm emphasizing this aspect of inspection because it's one of the advantages of using a dynamic language like Python and using an object-oriented API like we developed. Because, for instance, if you're programming the Arduino in the native language of the Arduino project, which is actually C++, if you think about it, we are doing things here that you can't do there. First, you cannot inspect variables like we're doing, and the pins there are not objects. Although C++ is an object-oriented programming, the API that the Arduino guys chose to create is not object-oriented. So you have functions that you pass parameters to turn pins on and off. You don't have a pin object. And for instance, if I have a pin object, I can do help on it. And again, through the introspection facilities of the Python help system, I'm looking at the actual docs for that class, the digital pin class. So I see there's a method called high, and a method called low. There's a method called toggle. There are properties, mode and state, and some other things that are not interesting now. So what can I do with it? I can set the mode to out. So out is a constant that I imported when I did from Pingo import star. And I can do LED toggle. And again, so I'm on, off. See the LED here? All right. So how do I remember? How many of you have played with Arduinos before? Yeah, cool. So this is the basic hello world, like I said before, the Blink program in the Arduino language, and the Blink program in the Python language is basically you import Pingo, you create the board instance, so that's 2 lines, and then you grab the pin that you want to control, and then you can do something like this from time import sleep. This is from the standard library, and now I can do while true, sleep for half a second, and then LED toggle. And so now we have a blinking LED, right? And everything that I did here works exactly the same on a Raspberry Pi, a PC Arduino, a BeagleBone Black, and so on. Because the line that I used to instantiate the board was using that detect feature. So if I don't even have to change that line. So the other part of the demo, which is trickier, but I'm going to do it anyway because I have time, is to do analog input. So I have a pot here, and what I'm going to do is I'm going to, again, just to make it easier to type, I'm going to get the A0 pin and assign to the pot variable. So again, I have an analog pin object, and I can again do help on it, right? And it has there's this method called ratio, which is a convenience method, because usually when you, for instance, in the Arduino API, when you read the value of an analog pin, what you get is an integer, and the lower bound is 0, and the upper bound actually depends on the resolution of the analog converter, right? So in the Arduino Uno is 10 bits, so the upper bound is 1023. But for other models and for other boards, you're going to have different resolutions. So in the spirit of Python that comes with the batteries included, we added convenience methods. So you can read the value if you want. You can also read a %. So this, regardless of the resolution of the analog converter, is going to give you a number between 0 and 100. And you can have this ratio that gives you by default a number between 0 and 1. But you can give it parameters to give you another range. So what I'm going to do with this is I'm going to write a little function called bar, because I want to do a simple bar graph, and I'm going to print a bunch of stars. Python has this neat feature that you can multiply a string by an integer, so then you have the string repeated. So the number of times that I'm going to repeat is pot ratio, which is a number between 0 and 1, times 70, okay? And now what I'm going to do is I'm going to do while true, and I'm going to sleep a little bit. And draw a bar. Whoops. Okay, I forgot to set the mode of the pin. So pot mode input, and so there you go. I am reading values and plotting a simple graph on the screen, right? So basically, that's the idea of Pingo, to make it as easy as possible to program these boards and to provide an uniform API that works across several boards. So let's go back to the slides here. So if I were to do that, which I just did as a script instead of doing it interactively, this is how I would do it. I wouldn't import from Pingo and import star, because that will be too many names in my namespace. I want to be more explicit in a script. So this is one way, for instance, of grabbing a board object. In this case, I'm specifying the kind of board that I want and giving explicitly the serial port that I want to use. This could be used. This is useful, for instance, if you want to control several boards at the same time. So, and this is basically the blink, right? This is another example. Well, I just translated this into English. It was in Portuguese about half an hour ago. So sorry about the line break here, which is wrong. But this second way is in the Arduino package. There is a function called get Arduino that will try and look at the serial ports if there is an Arduino connected and use that. Okay? And the third way is the most automatic way, which is the one that I used before. Again, the line break is wrong there, sorry about that. But this third way is easier to start, and it will make your program run on all supported boards without any changes. But sometimes this is not what you want. For instance, because the way this works is, if you look at the board that is actually running Pingo at this time, so if this script is running on a Raspberry Pi, if you know that it's running on a Raspberry Pi, and will connect to the Raspberry Pi itself. So the board that you're getting in this situation is the board where Python and Pingo are running. Often that's what you want. But if you're running Pingo on a Raspberry Pi and you want to connect to an Arduino that's connected to the Raspberry Pi, this doesn't work. So you can do it this way, right? Because in this case, it's going to explicitly look for an Arduino over the FIBATA protocol. Okay, and this is the most explicit way of doing it. So basically, 3 ways of getting a hold of a board, which is where everything starts, because from the board you reach the pins, and from the pins you have the methods to control them, right? So the code for the Arduino Dojo, the one that I showed you before, in different using different APIs of the different boards, is pretty simple, right? So I'm using a range. Oh yeah, this is another way of getting at the pins. If you get the pins property is basically a dictionary with all the pins. But often you care more about the digital pins than about all the pins. So there's this other property that gives you only digital pins, and this is a list. So you can use range. In this way you can actually, so with this line, what I have is LEDs as an array of pins, which would be the array of pins that are connected to the 7-segment display, right? So this makes it very high level. And now I have an infinite loop here where I iterate over the LEDs. And if it's the number 9, I'm going to skip because this is the middle one, for instance, and I want the animation to be just around the display. And this is basically it. And I skip for a time that is proportional to the pot position. Okay? So now some Pingo concepts, some of the ideas that are behind this. Sorry, some of this is in Portuguese. Actually, all of it is in Portuguese. And this too, sorry. Anyway, okay. So the principles are, the API is object-oriented, which means that it allows interactive exploration, like I showed you in the demo, and it's easy to extend to support new devices. How easy is it? Let me tell you. So, for instance, we were already supporting 3 devices, and another contributor came along at Garoa Hackerspace, and he was interested in helping the project. And I said, so implement the PCDuino driver. We don't have that yet. And basically, the next evening it was done, because I told him, look at the drivers for the other boards, see if one of them is similar to the PCDuino. Copy that, edit, and done. This was 40 lines of code. I'm going to show you that. Okay. So we prize usability, right? Which is, I think, the most important innovation of the Arduino, because the Arduino wasn't the first development board in existence, right? But it was the first one developed with usability in mind. To be easy for beginners. So you have the pins clearly labeled, and everything is very simplified in the Arduino. That's a great idea. So, and if you look at at other development boards that are even more recent than the Arduino, like the BeagleBone, it still has some of the problems of the past. Like, for instance, the pin layout is a complete mess. Right? So I think this is, if you've seen the picture of the new Arduino tray that's coming out. So the new Arduino tray is like a cross between a BeagleBone Black and Arduino Due. So it has lots of pins, but it is an Arduino project done by the same designers that did the Arduino. So if you look at the picture closely, you will see that the pins are logically numbered and very, well organized in the layout of the board. So this is challenging, and it's challenging because there is the numbering of the pins, the physical pins, but then there's this logical numbering, which is just completely, it seems like random. It's just not random from the point of view of the engineers who designed this thing. But for everybody else, it's completely random. And so, for instance, last year at PyCon in Santa Clara, there was a Raspberry Pi workshop, and I helped some beginners in that workshop. And I noticed that it was a common problem when people were trying to use the RPI.GPIO library in the Raspberry Pi, which is the most popular one, is that you have, the first thing you have to do before you do anything else, you have to decide how you're going to address the pins. If you're going to use the physical numbering or the logical numbering. And so, if you've studied usability, you know that modal interfaces are usually confusing, right? And this is an example of a modal interface. You set a mode, and so if you're looking at this long program, you have to know that the mode that was set was like this. And sometimes you're copying and pasting code from the web, and that code will not work because it's using the opposite numbering scheme, right? So in Pingo, we want to push for a standard mode, which is the physical numbering. So you don't need to decide that. If you don't decide it, it's the physical numbering. And we actually are not going to have another mode. What we are going to have, we don't have it yet, but it's very simple to implement. We want to have additional properties, just like we already have, for instance, like I said, these properties, the digital pins, and this other one is the pins. They're going to have another property. The name is not yet defined, perhaps GPIO pins. And this is another property that gives you access to the same pins, but using the other addressing scheme. So then it's going to be explicit whenever you access the pins anywhere in the program, which numbering scheme you're using, instead of having this configuration done somewhere. Okay. And we are using idiomatic Python. So, for instance, when you set the mode of a pin, that's actually a property instead of having a getter and setter. It's just a property, because for some board implementations, maybe you don't need to do anything, but for some others, the driver may have some special logic to set the mode. So currently, okay, what are the drivers? The drivers implement the control methods that are specific to each board. And as of May 2004, we have these 4 drivers: the Arduino Firmata, the Persiduino, the Raspberry Pi, and the Udo. And a cool thing that happened just last week, I want to tell you about this, is that suddenly somebody that we didn't know then started posting bugs on the repository, the GitHub repository for Pingo, claiming that our driver for the Persiduino was not compatible with the Persiduino tree. And then I looked at the name at the username, the GitHub username, and I heard about this company, Link Sprite. Who are these guys? Those are the Chinese guys who created the Persiduino. So then I commented on one of these bugs. I said, okay, so it's not compatible with the Persiduino tree because we don't have one. If you're the makers, please send us. And it's in the mail, they told me. Okay. So we're going to have, probably when I get back to Brazil, Persiduino 3 and 2. Okay, so the basic objects of the library are just 2. You have a board and you have a collection of pins, right? The board just has one method that is of interest of the end user, which is clean up. This is basically to set the pins at some known state. Some of the lower level APIs that we use recommend doing that before your program exits, calling clean up. And then you have the pin. The pin has two attributes: a board, which is a reference to the board where it's attached, and a location, which is the physical location of the pin on the board. So we have boards, right? For instance, we have the Raspberry Pi, the Arduino Firmata, the Arduino, for example, are three instances of the board class. The board class is an abstract class where we put the logic that is generic, and to create a new board driver, you basically subclass that and implement these methods with the underscore in front, which are they have an underscore in front because those are methods that the end user of Pingo shouldn't care about, right? And we have a mixing class for the analog input. So, for instance, the Arduino Firmata and the Arduino, which both have analog pins, inherit from this and from that, but the Raspberry Pi only inherits from that. So we have different kinds of pins, and this is kind of a, so we have the data pins with our digital pins, analog pins. We still don't have that, but we soon are going to have digital PWM pins. And on this side here, we have supply pins. So why on earth would we represent the supply pins in software, since we cannot actually control them with software? So this was an idea, again, on the line of trying to do it, make a usable interface. Because in some boards, like for instance the Pingo Black and the Raspberry Pi, there are actually supply pins mixed up in the middle of all the data pins. Representing those pins in software allows you to automatically generate maps of the pins, right? So that's the idea.
And then I guess the Raspberry Pi, the old version and the new version have totally different pin layouts too, does it?
No, not totally. Just a few. I have these actually on this picture here. It's just a few pins that change number. Like this one, just some of them. Yeah, some of them changed. But see, the physical number is the same, right? Yeah. So the thing is, but actually we don't support the earlier version yet. But it would be like a very simple change to have the earlier version, because all we would need to do is change a list that it does this mapping. So we could subclass the existing class and just change one attribute without touching any method, and everything will work. So what else? So yeah, the collaboration. So this is the reason why it's easy to create a new driver, because you don't need to program anything regarding pins. All the drivers, all the boards have pins, and we abstracted the So to create a new board, what you do is you create a new subclass of board, and this subclass, like I said, implements these methods, and these methods are used behind the scenes by the pins, right? So basically the logic of controlling a pin that's specific to a board lies in the board class. So you don't need to touch this at all. And another advantage of this is that as we create more pins and more components that I'm going to talk about in a minute, everything that we do at that level is going to be usable immediately in all boards, because the same logic, the same architecture is going to be used of delegating specifics to the board driver, which is just a board subclass. So what are our current plans? We want to have drivers for the new boards like Arduino Galileo, Arduino Uno, Pingo Black, Arduino 3. we want to restructure the tests. We started using the Python unit test module, but we don't like it very much because it's kind of burdensome to write all the classes and so on. We want to switch to the PyTest syntax, which is more function-oriented, and so it's less verbose. We already use PyTest to run the test, but PyTest has also this other API for simplifying the test writing, and we want to review that. We want to implement more specialized pins, some protocols, and parts. So what are the parts? The parts, I think, if you want to contribute to Pingo, this is probably the more interesting part to do right now of the whole project, which the idea is instead of just forcing the user of Pingo to deal with pins directly, he's probably or she's probably controlling the pins because the pins are connected to some component that's more interesting than a pin, like an LED or a servo and so on and so forth. So the idea of this is that we're going to have, for instance, an LED, just a very simple example. I have an LED object, and so I create this LED object, and I pass to the constructor of this object a pin object, right? And now, instead of controlling the pin, I call methods on the LED, which are higher level. For instance, I can have a fade-in method. If the pin provided is a PWM pin, I can do that. So I can call a method called fade-in and pass a number of seconds, and so the LED will slowly light up over those seconds, and this is going to be done on a thread. So your program can still do other stuff while the pin is, lighting up slowly, fading in, right? For an RGB LED, for instance, you will instantiate it by passing 3 pins as argument, and then you're going to have all these methods and some other methods, like for instance fade to. Suppose right now the LED is yellow and then you want to fade to green, so you're going to say fade to green and over 3 seconds, and the method can do that. See, so basically these are some objects that already exist in the Arduino library, but we want to implement them using a Pythonic interface. And the fun part of this is that as we implement this using the other abstractions that are already in place, when you create, for instance, an LCD display class for Pingo, this class is going to be useful for everybody that uses the BeagleBone Black, the Raspberry Pi, the Arduino, and so on and so forth, which doesn't happen these days. Right now, if somebody writes a class to make it easy to control a display like this on the Raspberry Pi, it's not going to work on the PCduino, right? So because we abstracted the pin controls, the controlling of the pins, and then below that, delegating through the board drivers, every effort that is going to be put into this is going to help everybody, that no matter which board they use, right? So join us, because this is a free neighboring project on the very initial stages. We started this about 3 or 4 months ago. So the interesting part of joining a project in this early stage, I've contributed to open source projects several times before, and sometimes they were older projects and sometimes they were younger projects. And the fun part of contributing to a very young project is that there are still some very interesting architectural decisions that have not been made. So the discussions that we have are very interesting. You know what I mean? For instance, if you start contributing to Django now, Django is already very well established. So the kind of contributions that you can do are either very simple, or you're going to have to put in a lot of effort and studying to be able to do significant contributions. And if you're thinking of architectural contributions, then it's very unlikely that somebody can be able to change the architecture of Django, right? So, but Pingo is still very green, so you can do that. And also, any contribution is noted and makes a difference, right? So we have the docs. I can show you the site. I actually would like to show the site, but I'm not connected. Which network can I use here? Can I use the network?
Yeah.
Yeah.
Space Lab.
Space Lab.
Yeah,
Yeah.
and the password is Space Lab is the greatest.
Mm-hmm.
All lowercase.
Great.
So,
There's a Mac disconnected.
for instance, if you go to pingo.io, this is our main site, documentation site. This is all generated using Sphinx, the wonderful documentation system of the Python community. So, for instance, here drivers, there's a list of the drivers and the current states and so on, types of the drivers, and there's a place here called contributing, and it gives you hints about contributing. We have a mailing list that, although every contributor at this time, no, actually we have these Chinese guys that are posting bugs, but almost everyone else in the project are Brazilians, so, but we make an effort of speaking English or writing English on the mailing list. So we welcome you because we decided to create the mailing list in English, okay? And we welcome everybody around the world. We also have the GitHub repository. Sorry?
Google Translate works pretty good.
Oh yeah, yeah. So, for instance, Pingo, here's the repository. Let me show you a driver. Like I said, the drivers are really easy so to do. The Arduino driver is basically this. Oh. See? 45 lines. And the other are not more complicated, much more complicated than this. One of the most complicated is the Arduino because of the Pi Firmata thing, and, but it's still like only 100 lines of code for the Arduino Firmata. Okay, so this is Pingo. Thank you for having me. If you have questions, I don't know if we have time.
Yeah, we have questions. I have a couple.
Yeah.
First of all, I tried to join the forum or the Google group and it said I don't have permission to join it, so I don't know if there's some.
Is that right? That's weird.
But so I have an actual question now too.
Mm-hmm.
So, how does you explained that there are 3 ways to detect, like, for instance, if an Arduino is connected to, or a device is connected to a computer. How would that work, or does it yet, or do you have anybody working on a way to detect, like, if you're using the software serial library, to have multiple Arduinos talk to each other?
Interesting question. The thing is, for the Arduino support, that is a use case that we don't cover because Pingo is a Python project, so Pingo will not be running on the Arduino. We are going to remotely control. So what we want is for every Arduino that you want to control to be running the standard Firmata sketch. So they implement the protocol, and then you talk to them from the computer that's not an Arduino that's running Pingo. That could be a Raspberry Pi, for instance. Does that answer your question? So because you said the soft serial is for communicating between. No, soft serial. I know it's just instead of using the onboard serial, is implementing serial over any pins, right?
Right. You take you take port 0 and 1 of one of the Arduinos, and then you hook them into whatever digital pins you want on another.
Yeah. So for us, this is not a use case that's in the scope of the project, because then you're going to have an Arduino talking directly to another one, and we always talk to the Arduino from a computer that's not an Arduino. And so if we have two Arduinos, the easiest way to do that is to have the central computer talk to them and not have them talk directly to each other.
Okay. Yeah.
Okay? Yeah.
That makes sense.
That's the idea.
Cool.
Any other questions?
How would you open them using the file like objects? Do they have separate IDs? Can you enumerate them? Can you get an index of them?
Sorry?
You have two Arduino, because you should address different boards by their types. Or what if you
No. Okay, let me go back to that part, because obviously it's the most confusing part of the presentation. So it is kind of a, so like I said, these are three different scripts that do the same thing in three different ways. So in the demo, I use this one, right? And this, like I said, will see if it's running on a board that the Pingo supports, then it's going to connect you to that board. So this variable board is going to get a reference to the current board. Now, if you want to connect to an Arduino, then you have this interface, which will give you the first Arduino that it finds as it scans the different serial ports. And this is only for the first one. So if you have two Arduinos, then you're going to have to use this other interface in which you specify this string is a specific serial port, right? So if you have two Arduinos, they are going to be connected to two different ports. And so you connect to one, you assign to one variable, because this is one instance of the Arduino Firmata class, and the other Arduino is going to be another instance of the same class with a different connection string.
How do you find the connection string for the other one?
Well, if you're using this API, you have to know the connection string.
Where does that ID, the FA13?
Okay, so what happens is, there's actually a way of enumerating the serial ports, and that's what we do inside this function here.
So does the 1341 refer to that one and not another one?
Well, to be honest, on a Mac, I don't know if you're going to know that before you actually write to them and see what's going on, because this is the ports. They are USB ports, and there's a lot of software layers on top of them. So it probably depends on the order that you plug them in. Also,
the best way to do it, you plug one in, you list the ports, you plug one in, you list the ports again, you plug the second one in.
Exactly.
And then whatever changes means the new device has been added to your computer.
Yeah.
Unique IDs in the device?
No. The devices don't have unique IDs. But the USB ports that the operating system sees have unique IDs, which are like this on the Mac. On Linux or something else, like TTY dot something.
So a long time ago, you could plug a floppy drive into the first floppy drive port and another floppy drive into the second one. And so the physical plug you are plugging them into would determine...
That's the interest of a plug.
Right. Well, so here we virtualize these connections into a USB port, which would work for the whole floppy drive analogy. You know, you've got two floppy drives, you plug them into your USB ports. Who knows which one's the first one and the second one?
Yeah.
You access it and you look at which light comes on. Oh, there we go.
Exactly.
That's kind of,
So his practical advice, what's your name, sorry?
Jay.
Jay?
Yes.
Yeah, his practical advice is very good. You know, you basically plug the first one in and see which one comes up, and that's the one, and then you plug the other one, and then you're going to have a different screen. So for instance, we actually don't have yet, but that's a good idea that your suggestion made me think of it. What?
Do it, by all means.
Yeah, to have a way of just a simple API to list, because we already do that. Well, there's a way of doing that using the Pi serial interface, which we use underneath, but we are not exposing that because we didn't think of this use case that you suggested. Yeah. And yeah, just out of as a practical matter, when I have problems with this, sometimes I use even the Arduino ID, because it shows here the ports. And when you teach Arduino to people, you say, oh, how do I know which one to choose of these many options? Well, basically unplug the Arduino, and some options are going to disappear. And then you plug on the Arduino, and some other options are going to appear, and one of them should work. But if you connect another Arduino, some other options are going to show up. That's basically the nature of the USB. They're supposed to be transparent, but when we are doing this kind of programming, the fact that they are transparent kind of hurts more than helps. Right?
So, are you familiar with the one-wire temperatures? One-wire protocol and their temperature sensors. That's what I use at the Raspberry Pi.
No, I'm not familiar with that.
Okay, they're really cheap. The temperature sensors work really well. They cost like $1, and you can string a whole bunch of them all on one serial port.
Oh, nice.
You can get, and
so
actually the Raspberry Pi Foundation already has the modules. You just import them.
So what's the name of the protocol? Sorry.
One wire.
One wire.
The number 1 and wire.
Oh, nice.
And
that's interesting.
So.
Like the thing that's $1 has some way, some little like.
And they have unique identifiers.
Yeah.
Every little chip, they're tiny little chips.
Oh, yeah.
As big as a transistor. And you can run them all off of one pin on the Raspberry Pi.
That's nice. Yeah.
Serial port.
So, for instance, before we started Pingo, we were doing, just experiments with different boards. And the experiments, we collected them here in this experiments folder of the repository. So for instance, if you go to the Raspberry Pi, because we needed to read the analog input of a pot or something, and so we needed to use this external AD converter, and the AD converter uses SPI. So basically,
SPI is similar.
Yeah. So we actually, at the time, the SPI module was not linked to it was not installed by default in the. No, it was even worse than that. It wasn't. You had to recompile the kernel of the Raspbian distro to have SPI at the time. So basically,
And there's also an I2C.
Yeah, it's another serial protocol. Yeah.
Right.
So this one we basically implemented in Python, a very extremely slow but functioning implementation of SPI.
And it's reliable.
Yeah, it's like just bit banging. This would be like soft SPI instead of. But now the newest releases of the Raspbian already come with the module, and you just enable in the configure, and then you have much better, faster.
Actually, you you have to load module on the Raspberry Pi.
Yeah. So, any other question? Okay, if you ever go to São Paulo, come visit us. São Paulo is a fun city to visit, and this is it. All right, thank you.